live. Okay, so good evening, everybody. This is our week 1 live session for HIT 226. In the past, I have had tutoring sessions, and this time I decided to call them live sessions, meaning that I would present you with a little bit of an overview for the week and then allow for Q&A, for questions and answers. Okay, so for this week, the agenda is to just go over the course in general, focus on week 1 content, go over the descriptive statistics in greater detail, including variance, and I know that was a concern. And then as I do that, I'm actually going to open an Excel document and work on it with you, and that will serve as a review for Excel, as well as give you some pointers for week 1 Excel assignment. And then, of course, I'll answer any other questions that may come up. Okay, and my plan is to continue this every week. For next week, the live lecture will be on a Tuesday, but it's going to be during the day at 1 o'clock. Okay, so from this point on, I will stop sharing this document and I'm going to share my screen. And then I will bring up my worksheet and we'll work from there. Actually, not right away the worksheet, but the course shell first. Okay, so here is my course HIT 226. It's going to come up right now. And as you know, it's going to be a combination. You have gone through the syllabus already. It's going to be a combination of quality management and data. And when I say data, really, it goes over the analytical aspect of it. And in order to analyze data, we need to review math. We need to be able to use Excel. And the assumption here is that you have had your math course, some basic math anyway. You have had your Excel course. So the hope is that that knowledge is coming back together and you're using it in a way that is meaningful and supports quality improvement. So that's the idea. Okay, so in week 1, basically, as you have seen, we have a bunch of chapters here because the idea was to get you started with the concept of quality and how we measure quality and what are the basic indicators in quality, and also try to give you a general idea of descriptive statistics. Because once you have that under your belly, then it makes it easier to analyze data moving forward. I know it says chapter 10 in that Horton's textbook, meaning that you probably would do it, if you were going just reading the book from the beginning to the end, you would do it at the end. However, as we talk about quality, it doesn't make sense to learn about the mean and the median or the range or standard deviation at the very end of the course when we in fact are going to use data throughout the course. Okay, so it's not really meant to challenge you in a way, in a negative way. It's really meant for everybody to help everybody move along throughout the course much smoothly. Okay, that's the idea. So with math, there is not going to be anything elaborate except for making sure that you know ratios and percentages and decimal numbers and things like that. Rounding is another one. Okay, and also there will be word problems down the road. So you need to use your critical thinking skills and just some basic common sense knowledge along with your mathematical knowledge. Okay, so now I'm going to bring up the worksheet. Can everybody see an Excel spreadsheet? It says exam scores analysis, and then it has some numbers. Okay, let me check. Okay, great. And you don't have to take a screenshot. I mean, if you're welcome, you can do that if you would like, but you don't really have to. Okay, because this is being recorded and you can go back to it. So what I did here is I thought maybe it will make more sense to talk about the various descriptive statistics, including measures of central tendency as well as measures of variation through an example, rather than going through slides and making it more theoretical. Okay, and then it is also similar to your week 1 assignment. Okay, so I have 20 students from 1 to 20, and then I have their scores. So this was a quiz or exam, and the total number of points they could get was 75. And these are their respective scores, 33, 34, 43, and so on, all the way to 70. Now, as you see, I deliberately put them in ascending order because it will make easier the analysis a little bit later, okay? Let me show you something as we're doing this. I said we'll use it as an Excel review as well, hoping that you guys know how to sort. So if you, let's say this was scrambled, and let's say here I had number 20, and this person here had 70 points, and then number 6 had 54, and let's say that that's the way I recorded the data to begin with. So if I select this area right here, so columns A and B, from row 4 all the way down to row 23, and I click on data and then sort right here, this button here, and then I can sort by student number from the smallest to the largest, and then it will be the way it was before. So I have the student numbers, okay, in the order I wanted them. Okay, so always try to, when you are sorting data, in this case, you saw me, I selected both columns. If you only select this column, then it will not move the score along with the student number. So that's very important, okay? So what am I doing now, right now? I am going to calculate measures of central tendency. So these are central tendency measures. And then I will also do measures of variation, which are range, variance, and standard deviation. Okay, and let me just bold these so we don't get confused. All right, so in general, what is mean? Mean is the average. Okay, so if you have if I'm looking at your ages in the threaded discussions, and somebody's 23, 25, 30, 40, and so on, what I usually do, and you probably usually do in your daily life when you have to do that, you add them all up, and then you divide them by the number of people, right? In this case, mean is the same thing. What I would have to do is add up all the scores, and you can do that with the AutoSum function. Okay, I can do here total. Okay, so the next thing that I could do is to get the total score, which is 1167, and I divide it by the number of students. How many students do I have? I have 20, right? Okay, very good. So, and then if you were to do it this way, you could pull in your calculator function, and then just type in 1167 divide by 20. And that gives you 58.35, okay, which is 58.35. That's the manual, well, kind of half automated way of selecting it. Now, let me do the formula. When you insert a formula, the first thing you do is put the equal sign, then click on the total, then put the division symbol, and then you will have to type in the number 20. As soon as you do that, you get the same result. And if you click here, and that's the way I would grade them too, I would click on the cell, and I would see that up here in the formula bar, I see that you actually use the formula function right there. Okay? Now, here is the third way of calculating mean. And this is much easier in Excel. Excel really helps out with that. If you just type the function equals mean, actually for mean, the term is average. Okay? So you go to the cell where you want to put it, You put the equal sign, you put the AV, select average, no average A, no average if, nothing, just plain average. Okay? And then it opens a parenthesis and it expects you to put the numbers, what the average of what. So you have to be careful here. You select only the values, not the total, because it will skew your results if you do that. So only from the first student to the 20th student, then you close the parenthesis, hit enter, and you get the same score. Okay? Is that clear? Everybody is okay with how to calculate the average? Very good. So what does it mean? The average score for these students for this particular exam was 58.35 points, and this is out of 75. If I am to calculate median, now median is the number that sits right in the middle of the values. So I have 20 students here, and the values have to be put in ascending order. So if I go from the 1st to the 10th, right here, this is where my middle is going to be. So I'm going to highlight these two cells just that we see visually. Okay, so our median will be right there. When we have an even number of values, as in this case 20 is even, there is no exact middle. The exact middle is nothing. So then what we do is we take the sum of these two values and we divide it by 2. If we only had 19 values, okay, sorry, by 2, and this would be equal to 63, okay? If we only had 19, so if we didn't have the last one, then the middle would be 62, and our median would be 62, okay? Now, let's do this by using the formula function in Excel. Again, you put the equal sign and then type in the word median. As soon as you start typing M-E, you see median, the word median. You click on it, double click, then select the range of values all the way from 1 to 20. You close the parenthesis and hit enter, and sure enough, we have the same result. Okay? So, just make sure you select the actual values and not the student numbers, because that's not going to be correct. This is what we're calculating, the median of their scores. Mode. What is mode? And please stop me if I'm moving through too fast here. You can just type a message. Mode is the number that appears the most. Visually, if it's a small number of values, you can just look through and find it. Here, I'm just going to use the formula function equals mode, and don't get mode multi single, you just type in mode. Actually, you could do the multi just in case that there are multiple modes. For example, if you saw 70 repeated twice, 68 is repeated twice, then you're not sure, maybe there's more than one. So you can choose that and then select all these values again. And well, I guess 68 was repeated the most. Yes, I see it's 3 times actually, 68, 68, 68. So it did have just one mode. Okay, so these are the measures of central tendency. Any questions on these? Okay, great. Range. Range is literally the difference between the largest value and the smallest value. So in this case, it would be equal to 70 is the largest score that was obtained. Thank you, Stacy. And then the smallest score was 33. And if you do the math here, it ends up being 37. What does it mean? It means that these scores were really, they varied a lot. You could really say that there were students in this class that got it, and there were others that really did poorly. Okay, that's what variation means right here, the range. Okay, so their scores were distributed a lot. Now, if everybody, or in a class, let's say a class with students from 18 years old to maybe 60 years old or 57 years old, you can say that the range here is huge, from 57 all the way down to 18. So that gives you a really high dispersion, and it makes it more mixed, more diverse, and perhaps a little more difficult or challenging to handle. However, if you go to an elementary school and you're going to a first grade or second grade, everybody there is going to be perhaps, 6 years old, 5, 6 years old. And the most they differ usually is about a year, that's it. So there, the range is much smaller. The differentiation between the values is much, much smaller. They are more homogeneous. That's what this means. About the formula, you put the equal sign, put the word range. Actually, for this one, I apologize. You would put equals minimum and maximum. Okay, so we're going to find the maximum value first. Okay, and out of these, and again, here it doesn't make that much sense because we already know. So this is our max. Okay, or I can just put here, by the way, if you right click, you can insert a comment and say max. Okay, and then here I can do minimum value and select the range again, all of these values, and here's our minimum. Here's another comment, minimum. So as for the range, then we do max minus min, and that's 37. Okay, so you take it's not totally shortcut, but you do the maximum and then the minimum. Again, if you're talking about sheets and sheets of data, Excel functions really do help tremendously. Okay, now let's move to variance. Okay, variance is a little bit more difficult to understand. So what happens is that what we try to do is calculate the differences between each value and the mean. So if I were to put here, if I mark this an X, and let's say our mean is X bar. Okay, right here, this is marked as X with a bar on top. Okay, um, I can't draw it like that in the Excel spreadsheet. I'm just going to say here, I'm going to mark it as X1, and hopefully that will make sense. Okay, so, or I can just say mean. So I can do X minus mean, and that will be more clear probably. Okay, so basically what I'm doing is putting the equal sign. X value is 33 minus the mean, which is 58.35. Okay, and I hit enter. So the first score is different from the mean, and it's lower than the mean. It's 25 points lower than the mean. That's how you interpret it. Now, rather than doing the same thing for each of them, I can just copy that all the way down. Okay, and let's see. What happened here is it copied. Okay, never mind. So let me undo this. Okay, you see what happened here? It actually did not take the 58.35. It took the next value, which is C27, so it went down, taking the respective cells. And I don't want that. I want the constant value. So I'm going to change this and make it a fixed number. And there are some other ways to do that in Excel. If you remember it, there is a certain string that you use. Anybody remembers the use of string in Excel to make it a constant value so it doesn't change? Well, I'm not going to confuse you, but you probably did that in Comp 100. That was, yes. Well, if if it requires a lot of time, then again, what you do to make sure it remains constant, because that's what you want, just type in the value and it will remain constant. So basically, what we did here is calculated the differences between each value over here and the mean. And let me just clear the format here so we have no confusion. Okay, so now if you were to do to measure, what we're trying to do is find out on average what is the difference of each value from the mean. Okay, so that's what the idea of variance and the standard deviation is. So we're trying to figure out these differences that we calculated. What is their average? See, the minus 25, the minus 24, minus 15, minus 13, all of these, and 11 all the way up to 11 here. So how would we calculate the average of these? Well, one idea is to sum it up and then divide by 20. But you know, thing is, this doesn't work because these differences are going to end up as 0, this sum here, because between the minuses and the pluses, you know, it all goes back to 0. Therefore, what mathematicians have come up with is do their square. So what you do is just you multiply this by itself. That's the square function, okay? So it would be equal this times this number again, and then you move forward, you copy that all the way down. All right, and then you divide this by the number of values, okay? So this is how your textbook explains, calculation of variance, okay? So you basically take the sum, and let's do the sum here, okay? So the sum, I'm just writing the word sum so that we know what we're doing. And I'm going to make these red. Let me check the chat box for a second here. Isn't the number of values minus 1? Yeah, I haven't gotten there yet. Yes, voila. In fact, it depends on whether it's a sample or the entire population. In advanced statistics, sometimes it's 1 and sometimes it's n minus 1. I mean n or n minus 1. N being the number of values that we have. Okay? No, that's great. That's a great question. Yes. So we have the sum, okay? And the variance here is marked as s squared, okay? So it would be equal to, if we were to use our traditional formula right here, then we do the sum of the squares, okay? Divide by, and then we have n minus 1. N is 20, minus 1 is 19, right? And that's our variance. Now let me move this up here. I'm gonna put it up there. Oops. I'm not sure what happened there, but that's not standard deviation, that's our variance. Okay, so we're still with variance here. Okay, so and Excel does this, they automatically do things, you have one and then the next one it gives you 2, so you just have to be careful with those formatting issues there. Okay, so fortunately in this class, you will not be asked to do this. The reason I did it is just to kind of get an idea how do these numbers come about, and just to make the understanding of standard deviation easier, because you will see standard deviation is a square root of this. Okay, so what we started doing is, okay, let me check, sorry. Okay, that's fine. Stacy, did you have a question that you wanted me to address before leaving? Because I can address it now, And if not, yes, you can certainly listen to the recording. Okay, so again, what we tried to do is figure out how far from the mean each of these values were. And because we couldn't do it straight with the differences, because it gives you a 0 in the end, we ended up calculating their putting them to square, and then finding out the variance. Variance shows you how big these values are, apart from each other, kind of, not exactly, but that's the higher that is, the higher the dispersion between the values. Okay, now standard deviation brings it right back to the level where we started, and by taking the square root of that, it makes it easier to work with. So let me do the formula function here. Start typing equal variance and just go straight to VAR, not var P, not var S, just VAR. Okay, and then back to our scores. Okay, because normally you wouldn't have to do all the squares and all the square roots and everything like that. Okay, sure enough, you get the same number. Okay, does that seem much easier? Okay, so this is the formula. And then for the standard deviation, it would be the square root of that, but we don't have to go there. We'll just type in STDEV, that's a standard deviation, back to the same values, close parenthesis, and it's 12. And it makes sense, 12 squared, it is about 140, 144, so 12 point something, it's going to be 146 point something. Now, this is the value you are required to interpret. Okay, what does it mean? You look back at the scores right here, okay, and let me just highlight them and highlight this. So what you're making sense of is, what is the average difference from the mean? So if you look at these scores, on average, they're about 12 points off from the average. That's what this means. So these exam scores individually, okay, have different lengths or distances from the mean. However, when you look at them as a group, on average, they're about 12 points far from the mean. The 12 could be plus or could be minus. So they could be 12 points less than the mean, or they could be 12 points more than the mean. Okay, so that's how you interpret the standard deviation, and that is very important in your week 1 assignment. So take a look at that and make sure that you verbalize this and you write that down. As a principle, the higher the standard deviation value, then the higher those those distances are, right? So the far apart from each other the values are. But the smaller standard deviation, then the closer to the average these scores are. And it means that kind of in this class, in this particular example, everybody was kind of on the same page. So that's really, what this means. Does that make sense? Because again, you're going to have to explain this in one sentence or a couple of sentences, it doesn't matter, but I really want you to interpret standard deviation. And these are questions that may come up in exams, not just in this class, but in the RHIT exam. So remember, the higher the standard deviation, the higher or the farther from each other the values are, and from the mean as well. You can resubmit, Wyla, and any others who might have submitted. Yes. Okay. And then the smaller typically this is, then the closer to the mean they are, the more homogeneous they are. Okay. I'll go through a couple more things here just to explain decile or percentile and quartile and all of that, and then I'll be done with this part of it. Okay, so with the percentile, I'll just pick any cells here, or maybe just go down here. Percentile. Let's say we want to find, I don't know, the 45th percentile. Okay, So how do you do that with a formula? If you have to do it manually, I have explained it in one of the recordings that I posted, and there are some instructions in another document in doc sharing, so make use of that. But right here, the easiest way is to use the formula, and I put equal to, and you start typing the word percentile, and you go down to the plain percentile, and I highlight again all the values that I want, and then close the parenthesis. The next value I need to put is the actual percentile. Now, the key here is to put it as a decimal number. Don't put 45, but 0.45. And I need to close the parenthesis. There. Okay? So what we have here is that the value that would be found in the 45th percentile is 61, is right here actually. Okay? So this is where the value in the 45th percentile would be found. Yes, so is the comma between, yes, Wyla. Yes, let's do another one. So let's do decile. Decile, let's do the 20th decile. Now, there is no formula for decile, but the decile really is what? Is the second, I'm sorry. With deciles, what we're doing is we're decile, and this is the second decile, not the 20th. Okay, so let's remove this. So the second decile is really the 20th percentile. So use your critical thinking, or if you're asked for the fourth decile, it's really the 40th percentile, because deciles go by 10 and then percentiles by 1. So here you put the word percentile again, and then highlight the values, put your comma, and now what we record is 0.2 because it's the second decile or the 20th percentile. The 20th percentile is put as 0.2 in decimal numbers, and it's 45. So right here, and that's our, this one or that one. So these values here are in the 20th percentile. For the quartile, let's say the third quartile, there is a formula, quartile, and you select quartile, and then you select the numbers again, and then now you have to put, quartile, the actual number, which is 3. Okay, and it's 68. All right, any questions on this? Very good. One last thing, and I'll let you go. I'm going to go straight to the ebook to show you some graphs on normal distribution, because you might see these in exams, not in this particular one. Okay, I'm going to go to chapter 10. Okay, and let's, oh no, this is chapter 9, Descriptive Statistics, chapter 10. Okay, so let me go right here. Okay, and if you scroll down, I just want to go to the graphs that show the normal distribution. Remember, we just said that the higher the standard deviation, the more spread the values are. Okay, this is an example. Thank you. Yeah, I found it. All right, so this is an example of normal distribution. What does it mean? In the middle, right here, okay, this is the mean. In the middle, the highest value is the mean. So normal distribution means that you have about an equal number of values below the mean and above the mean. So on the left, you have any values that are below the mean. On the right, you have any values that are above the mean. See, the mean is 6.5, and then you have the numbers that are higher, 7.58, 9.5, whatever, all the way up to 12.5. They are higher than the mean. Then on the other side, you have numbers that are lower than the mean. So if you had a group of students, about half of them, did um, about 2, 3 points or 5 points less than the mean, and the other half of them were about the same number of points above the mean. Okay, when these differences go up to 3, 1, 2, 3, it's really close and it's really tight, and it's considered to be normal distribution. And these are very important percentages to remember. So if you have about 68% of your values about -1 +1 from the mean, so just a little bit of a difference from the mean, and then about 95% of them that are -2 +2, so just a little bit more distance from the mean. And then almost all of them, 99.7%, between -3 and +3, which is the difference again from the mean. That is considered normal distribution. Okay? And it's really ideal, but we don't get that often. Okay, so about 68 -1 +1, 95%, and all the way to 99%. So if you have numbers like this, standard deviation of 1, 2, 3, or even 4, usually it's pretty tight. It's pretty small. Values are close to each other. On the other side, they don't always look like that. Here again would be the mean, right here in the middle, the highest peak. Okay, and in this case, you have a lot more that did much better than the mean. They excelled. They were better than average. And then there were a few that were worse than average. This is considered to be positively skewed. Down here, here's the mean. We have a lot more below the average and just a few above the average, and this is negatively skewed. And there's others, of course, where you have more than one mode, and but this is mostly what you're going to deal with in this course. And again, this is an important one. That's all I had planned for tonight. Do you have any other questions that you would like me to address? Okay, I'm glad that this helped. Okay, great. Then I will end the recording, and I mean, we can. I can certainly continue to answer any other questions. Any other questions about this particular week? Okay. Well, then let me end the recording. Thank you.